Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, I'll go through this group 7 as part of the year 11 combined science chemistry section, which is dealing with periodic table, and in this tutorial video is specifically on the halogens. Speaking of which, there is the name given to the elements in group 7. We call them halogen, just like group 1. Just to recap, group 1 metals, they have a specific name. They are called the alkali metal because they dissolve in water. They react with water to give you metal hydroxide, which is alkaline, which is pH greater than 7 in solution. Alright, so group 7, they are non-metal. They are specifically called halogens. And group 8 has a special name as well. They are nonmetals. They are called noble gases. They have fully filled outer shell, and therefore they don't react with anything. They don't form bond with anything. They're just happy existing as atoms. Now, in terms of melting point, going down group 7, so this group 7 is the opposite trend to the metals. So we know that F2Cl2, Br2, and I2 is a solid, Br2 is a liquid, F2 and Cl2 is a gas. So this means you have already boiled, you have melted, but you haven't boiled, and you haven't even melted. So what does that tell you is that it becomes more difficult to boil. If you are more difficult to melt or to boil, therefore melting point increases, boiling point increases. There is another English term for it. It's called volatility. Volatile means it boils easily, so it becomes harder to boil, means volatility will decrease. You just don't know when this English term is going to come in because it's a Cambridge exam, even though we just know melting point and boiling point increases based on these, but you got to know the English term volatile. A volatile person gets angry easily because a volatile person boils easily. So the fact that you become harder to boil, so your volatility decreases. This question is on melting point, so I can go straight to the point. No need full sentence, just straight to the point. Melting points increase. That's all. Now state the meaning of the term diatomic. Di meaning 2 times. You can imagine that I've written all of these with a 2 at the bottom. That's the subscript. That's because group 7 elements. Group 7 element has something, comma 7, because 7 valence electrons. When you have 7 valence electrons, you need to share 1 electrons with a non-metal. Need to share 1 electrons with non-metal in order to form 1 covalent bond, and therefore then you can get to 7 plus 1, which is 8 electrons, fully filled outer shell, unreactive. That's what you call a fully filled outer shell, which is the main objective really. Okay, so diatomic means 2 atoms bonded together. Diatomic means 2 atoms bonded together chemically. So it form a chemical bond. In this case, it's a single covalent bond because they only share 1 electron there. Part C, this is a type of reaction called displacement. So in terms of displacement, we think about F2, Cl2, Br2, and I2. So we say that is more reactive, going up that group. So the more reactive you are, you can displace the less reactive halogen from the halide. So you have halide. Halide is an ion, is an X minus. So F minus is called fluoride with an IDE. This is also IDE. And then Cl minus is a chloride, and so on and so forth. Bromide as well as iodide. So that's what we mean by halide ion and halogen molecule. Now, why iodine is displaced by bromine? Bromine is above iodine in the reactivity series, or bromine is, well, when I say reactivity series, I mean in terms of group 7. So bromine is more reactive halogen because it's a more reactive halogen molecule than I2, or Br2 is above I2, or Br is above I in the periodic table, is a more reactive halogen than that. Therefore, Br2 can displace I2 from I minus. The fact that I2 is at the very bottom means that I2 is the least reactive. So if you have I2 plus Br minus, you will not have any reaction. I2 plus Cl minus, no reaction. I2 plus F minus, no reaction whatsoever. Why chlorine is used in the purification of water supplies? So what does chlorine do? Chlorine kills harmful microorganism or harmful bacteria, whichever word you like. Just make sure you can spell them, as well as just make sure you go straight to the point. So chlorine can kill harmful bacteria and microorganisms, therefore it can sterilize or it can make water supplies safe for drinking. On to the next question. So this is about displacement reaction. So you have NaBr reacts with Cl2. Remember just now, Cl2 is above Br2, so Cl2 can kick Br2 out from Br minus. Therefore, when you have this reaction, you get Br2, and you will kick Br2 from Br minus, and the Cl2 becomes Cl minus. The color at the end of the reaction is going to be the color of Br2. So you will see, we will see orange yellow solution. The fact that we see orange yellow solution rather than reddish brown because we have aqueous. Aqueous mean in water. If you have pure halogen, if you have pure Br2, that means you will get reddish brown. Br2 is a reddish brown liquid at room temperature and pressure. Cl2 is a greenish yellow gas. I2 is a black solid at 25 degrees Celsius called room temperature. But these are in aqueous solution, so you dissolve in water. The color is a bit diluted, not as strong. It's around orange yellow color. Now you want a balance and you want a symbol equation. So what we have, we can refer to the previous equation. You can imagine this now is Cl2, now is 2 NaBr, and you get 2 NaCl plus Br2, but you should be able to balance this on your own. So we started with NaBr, we reacted with Cl2. The Cl2 is above Br2, so it will kick Br2 out, and then it will take the place of the Br minus, such that you get this and that. And now you have 2 chlorine, so I need to put 2 there. And now I have 2 sodium, I need to put 2 there. And now I have 2 Br, I need to put, well, I don't need to put anything because there's 2 Br already for that 1 mark. Moving on to the next question. So we have an atom of fluorine. Fluorine is a group 7 element, so it's period 2, but it's group 7. Period 2 means there are 2 shells, first shell and second shell. This is the nucleus, which contains protons and neutrons. Proton number is the number of protons, so you got to count the black color one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then they say for this atom, be very careful for this atom, not from the periodic table, not from periodic table, because the next one is the really tricky one. Nucleon number. Nucleon refers to all the particles that stay inside the nucleus, which include the protons and the neutrons. So you got to count the black and the white color one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you got 19 there, because this is what I counted, not from the periodic table, but for this atom from the diagram given. Nucleon refer to protons and the neutrons in the nucleus of an atom. These are in the syllabus. Candidates should be able to state what is meant by proton number, what is meant by nucleon number. They are part of the learning objective or lesser objective, which you have done back in year 9. Complete the diagram, so do not leave any questions. They say electronic structure. So how many electrons are there? This is an atom. An atom has no charge, so the number of electrons equal to number of protons. If we have 9 protons, then we will have 9 electrons. How are you going to distribute it? It's going to be 2, 7. First shell, second shell, because it's in period 2. 7 valence electron because it's group 7. 2 plus 7 give you 9 electrons. So I'll use cross. And I have 7 electrons in my outer shell, the second shell. State the general name given to the elements in group 7. We did this in the previous question. You will see that this is a very popular question. Halogen, halogens would be alright. Reactivity of the element changes as the group is descended. Descended means going down. We learned about the displacement reaction just now. F2CO2 Br2I2. I showed you previously that the higher you go, these are more reactive halogen. More reactive halogen going up the group. That means this can displace, this can kick out Cl2 from Cl minus, this can kick out Br2 from Br minus, and this can kick out I2 from I minus. Cl2 can kick out Br2 from Br minus, Cl2 can kick out I2 from I minus, but Br2 cannot kick out Cl2 from Cl minus because it's less reactive than Cl2. Refer back to displacement reaction. So down, or I can say descending, that means the same thing. Descending group 7, reactivity decreases. Reactivity of the halogen decreases going down the group. Fluorine is a non-metal. What can be deduced from the symbol and its electronic structure? Okay, so what can you tell from this symbol? 9F. So this number on top, remember, it tells you nucleon number, which is the number of proton plus the number of neutrons. This tells you that there are 9 proton because that is your proton number. So what does it tell us? 9 protons, 19 nucleons, they say from the symbols. Therefore, number of neutrons equal to the top bit minus the bottom bit, which is 10 neutrons. I wonder if I can shift that a little bit to the side there so that I can get a bit more space. I think I can. And I'll move this out a little bit, otherwise it look a bit awkward there. Okay, cool. Alright, so 10 neutrons. Number of neutrons in 19 minus 9 is 10. So that's my number 1 point. And my number 2 point was about the electronic structure for an atom. So it's kind of repeated from the previous question, the earlier part of this question. But again, it's very good to see how the same type of question could be asked in different way. So for an atom with no charge, they call it electrically neutral. Therefore, number of electrons equal to number of protons. So therefore, 9 electrons. But they're asking specifically on electronic structure, how you're going to arrange the electrons. 2 in the first shell, 7 in the second shell. So that is the electronic structure. I go straight to the point, answer the question. Part B, fluorine reacts violently with magnesium. So this is your group 7. This 2,7. Magnesium is your metal. Is your group 2. Is your 2,8,2 because it's first shell, second shell, third shell, 3 periods, and it's in group 2. Name the white solid. So metal plus non-metal, you're going to get ionic bond because of type of bonding between metal and non-metal. What happened is the metal will lose the electrons. The metal will lose the electrons, and the non-metal, they will gain electron because your partner is a metal. And because your partner is a non-metal, you will lose electrons. You can imagine that the 2,8,2, it will lose one to the 2,7, and then it will lose another one to the 2,7, such that you need 2 times F minus and 1 time Mg2 plus, so that your formula is going to be MgF2. This is your ionic compound. Learning about chemical formula is a year 9 concept now that you're in year 11. They want the name, they don't want the formula. The name is going to be magnesium. It won't be fluorine, it will be fluoride. Make sure you can spell these properly based on the periodic table, but without the N because it's now a compound. It's got F minus, which is fluoride ion. Moving on to the next question. So we have chlorine. State the group in which chlorine is placed. Group number has to be based on the periodic table. So this is Roman numeral. You cannot use the Arabic numeral, which is 7. This is not allowed at all because this is given the periodic table. Now use the information use the information in the figure above. Give a reason. You must use the information. Now we know group number tell us how many electrons are there in the outer shell. So 1, 2, 3, 4, 5, 6, 7. There are 7. The diagram shows 7 valence electron. The diagram shows the one I've highlighted in pink a little bit. It shows 7 valence. If you don't like valence, you can use the word outermost. Okay, valence electrons. There are 7 electrons in the outermost shell. It's the same thing as saying there are 7 valence electrons. That's why it's group 7. Now, chlorine exists as diatomic molecule. In the earlier bit of this tutorial, we talked about diatomic, meaning 2 atoms combined together. Now, draw a diagram showing outer shell electrons only. So what I'll do is I will have a circle. And of course, you don't want to spend too long drawing your circle, so make sure you don't spend too long drawing your circle. So chlorine and chlorine. What I'll do is I have to show using dot and cross. So dot and cross. I only share 1 electrons because each chlorine is already 2, 7. So this chlorine requires sharing 1 electron. Share how many electrons to get to fully fill out the shell. So each chlorine will share only 1 electrons. This gives me a single covalent bond because 2 electrons being shared, 1 from each atom, give me 2 electrons shared total, giving me single covalent bond. They want you to show outer shell electrons only. That's why I show, oops, I made a mistake. It's actually 2H7, I beg your pardon. So 2H7 because it's in the third shell, yeah. Anyway, so 7 electrons in the outer shell. Do not just show this, you will not get the 2 marks. Make sure the other electrons, you started with 7, but you only use 1 for covalent bond. You still have 7. You still have 6 more, sorry. You started with 7 dot originally. That means you use 1 for bonding. You still have 6 more, which, you know, are not used for bonding. So I still have 6 more dot as shown here. Next up, chlorine reacts with potassium iodide. Remember the reactivities of the halogens. So they become more reactive. So more reactive going up the group, or you can think about less reactive going down to group 7. So this one is chlorine kicks out iodine. Chlorine kicks out iodine because chlorine is above iodine. Chlorine is more reactive than iodine, and therefore chlorine can kick out iodine from iodide. Iodide is I minus and iodine is I2. So this type of reaction is what you call displacement. You have seen 2 examples in the previous 2 questions. It's a very popular concept that always come up for group 7 chemistry, so make sure you know the type of reaction and what this reactivity mean. Constructing equation is very popular as well. So Cl2 plus potassium iodide, so K plus and I minus. Make sure you know how to get formula from your year 9 chemistry in combined science curriculum. K plus Cl minus, as you could see, IDE, so it's ion, K plus Cl minus, and you will kick out iodine. We got to write balance equation all the time, even when they don't ask us to. There are 2 chlorine, there's only 1 chlorine, so put 2 in front. There's 2 potassium, there's only 1 potassium, so put 2 in front. There's 2 iodine, and there's 2 iodine. This is now nice and happy there. This is the last question that we'll do for this group 7 tutorial. This is on bromine, diatomic again. So what is the name given to the group 7 element? Is halogen. What is meant by diatomic? It means 2 atoms chemically combined together. In this case, they are forming covalent bond because they are sharing electrons between non-metal and non-metal. Group 7. Part C, you have a solution of bromine in water. Bromine in water is what you call aqueous bromine or aqueous Br2. You use it to test for unsaturated hydrocarbon, which contain carbon-carbon double bond, versus a saturated hydrocarbon, which contain carbon-carbon single bond. State what is observed. Alright, so what is observed with carbon-carbon single bond is solution remains orange-yellow. So it's not liquid bromine, it's aqueous bromine. So it's not the color of pure Br2 liquid, but it's the color of aqueous bromine, which is orange-yellow. or some books or some teacher would just say orange, some teacher would just say yellow. I like to use the term orange yellow. The unsaturated hydrocarbon, the orange yellow solution will turn colorless. So I will try to be as complete as possible because you want to say, what do you observe? What do you see? Yes, you will see colorless at the end, but what happened at the very beginning? The orange yellow solution turns colorless. It goes from orange yellow to colorless because you can add across the unsaturated carbon-carbon double bond. You can't do addition, you can only do substitution, replacing the CH with something else if you have saturated hydrocarbon. Last but not least, this is the idea of a displacement reaction again. So F2Cl2 Br2 and I2. The higher you are in group 7, you are more reactive halogen. If you are the more reactive halogen, you can kick out the halogen from the halide of those below you. Bromine is above iodine. Bromine is above iodine in the periodic table. So bromine is more reactive than I2. All right. But then they say, why bromine cannot react with Cl minus? Why Br2 cannot kick out Cl2 from Cl minus? Because Br2 is below Cl2 in the periodic table. That is not good enough. We got to talk about reactivity. So this idea of displacement is always coming down to reactivity. This is not good enough. So we need to talk about reactivity. So Br2 is less reactive halogen than Cl2. So you can't kick out Cl2 because you are less reactive halogen than Cl2. You can't kick it out from Cl minus. They don't ask you for an equation here, but just like previous question, they could very easily ask you for an equation. Br2 plus potassium iodide, K plus I minus, group 1 metal, group 7 non-metal, K plus lose 1 electron, I minus having gained 1 electron, K plus I minus. And they will give you they will kick out the I2, and then you will form K plus Br minus with the same kind of formula, except that is Br minus instead of I minus now. Balancing the equation, 2Br, so 2KBr, 2 potassium, so 2Ki, and then 2 iodine just like that. So this reaction happened, but then we are saying that bromine with KCl does not happen. All right, that's because bromine is less reactive than chlorine, but bromine is more reactive than iodine, therefore this reaction can happen. You will see like a brown solution because iodine in water is like a brown solution, so you will see a brown solution. And name the products. They want name, you cannot give formula, so I have to say iodine, and I have to use potassium bromide because just now was potassium iodide, so now I have potassium bromide because K plus Br minus. Okay, so I hope that has been useful as part of the overall overview for the Group 7 Chemistry. They often come up for the Combined Science curriculum. Thank you for watching, and if you found that useful, do subscribe to the channel. Click the button on the bottom right to do that. And share the channel widely with everyone else you think might find the channel useful. Follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected, and see you in the next tutorial video.